Anyway, yes. Also, definitely generally appreciate you're like actually asking questions rather than observing silently. So much more motivating. Though also feel free to drop off whenever because it's kind of late. Um,
I'm very good at asking stupid questions. I can do it all day.
it's a beautiful life skill. I'm still extremely proud that when I interned at James Street, they said at the start, no intern has ever asked too many questions. And at the end, I was told you asked an appropriate number of questions. It would be bad if you asked more questions, which I take as a crowning life victory.
Nailed it.
Anyway, all right. So my current hypothesis. Okay, so I should probably actually take screenshots because some of these things have felt insightful. So this is the bracket coefficient. It's like mostly 1.5 to 2. Okay, no, the violin plot is just better than the box plot for this, even if I don't trust it. It was like, all right. And then next result is that correct logic attribution. Neurons looks kind of coherent. And at peak is for attention noise. It'd be kind of wild if all of this is just to control for the fact that the head is polysemantic as fuck and doing a lot of different things. And thus the attention pattern has significant noise combined with like how far you are into the brackets also messing with things.
So that would mean that you'd kind of not trust the signal if you're getting a signal that there's loads of brackets because maybe it's attending to something else or
Um, yeah. So I guess my current intuition for what's going on is the model is saying, okay, if I'm inside brackets, then I'm going to look like this. If I'm inside brackets, it's going to be like about this range. If I'm not inside brackets, it's going to be about this range. YOLO, I'm not super sure of the details. Is like my current interpretation. So uh I probably should I'm gonna go run this on like 100 strings of text just in case. Um and uh how do I make this data into a bunch of strings that are appropriately long? Anyway. Yeah, okay. I want to pick like 100 texts and roll with those. And now I just write boring munching code. Let's see. If this going to be enough to break my GPU. This is like batch 100 times 1,000, and it's 50,000 vocab divided by gigabyte. Nah, it's gonna break my GPU. Let's do 20. That is an acceptable number of gigabytes. And let's also do this in autocast. How does autocast even work?
Is this just a faster way of not having to write .2 device equals CUDA all the time?
No, sorry. Autocast sets it in mixed precision. So what this means is that we'll run the model in bfloat 16 internally, which actually I was going to do because bfloat 16 is smaller, but this is probably just me over optimizing, and who cares? Yeah. Okay. I'm being dumb and I should just do it like this. But yeah, autocast is convenient because so often you'll want to do the matrix multiplies in bfloat 16 because that's something like 3 to 8x faster than doing it in float 32, especially on modern GPUs, which are pretty optimized for it. But on the flip side, you often don't want to do like softmaxes in bfloat 16 because that is weird and breaks things. And maybe you want to keep your parameters or gradients in float 32. And autocast casts things to bfloat 16 for the hard bits like matmuls and puts them back into float 32 for like the less hard bits. Though I believe, I don't know how much this saves you memory. And then separately, you can just do model.to torch.bfloat 16, and this should also just kind of work. Anyway.
And when you say it's weird with softmax, presumably it's just you lose a little of accuracy doing softmax without floats? Or...
Yeah, I've never tested this. This is just like fuzzy received wisdom that you shouldn't do softmaxes in bfloat 16 if you can avoid it. My guess is it's just like matrix multipliers, they basically work fine. And these are the bits that's like actually costly to do in code. Softmaxes, they're weird. It's also possible just no one cares because softmaxes aren't a bottleneck for big models. So they might be a bottleneck for small models. And if you're doing stuff like 100K contact window clong or something, maybe this matters. I continue to really appreciate clong as a name. It's so great.
Sorry, what is Clong?
Oh, clong is 100,000 tokex context window Claude from Anthropic. And it is nicknamed Clong for Claude Long. It's beautiful. All right, so all right, so which I have stunning variable naming skills. Oh, wait. What? Why is this sad? What? Anyway. Yeah, so the thing which I am trying to do, if I ever get properly around to finishing it off, is taking the cumulative. I want to just plot a box plot of like cumulative sum of brackets against everything else. Where but oh, but oh, these are all reasonable things to complain about. Okay, so And let's also do each of these as a violin plot. All right, so this is telling me that bracket direction goes up with cumulative bracket depth, which sure would be an awkward thing to be false.
Sorry, how is this plot different to the previous one, apart from having 3 on the x-axis as well?
It's got more data. All of the bullshit
Okay.
munching I did up here was just getting me 20 strings of 500 tokens each.
Yep.
And yeah, and we'll get back to taking notes of pretty graphs. Okay. Okay. I'm trying to figure out whether I want to take this as a tentative win for my hypothesis or not. So it clearly is the case that being further nested gets you more likely to be this one and less likely to be this one, but also all of the numbers are just kind of low. And this is annoying. I don't know what to do about it. Nah, it also sucks at these. Anyway, this is a rabbit hole. What is my GPU memory at? Oh, it's chill. I could have gone so much more hardcore. Yeah, one thing which makes this particularly obnoxious is that I sorry. One thing which makes this particularly annoying is that there's going to be all of these like brackets and selfs and like other things that are weird, which are inside brackets, but where the model has carved out special cases for them. Anyway,
You mean it's like one reason that there might be like less probability on closed bracket is because there's like other context in there to say that actually I think the next token is just self or whatever.
yes. Yes. And I guess some more ideas. That could be MLP out, direct logic effect, as code cache, LP out, 0 times the final Leonard scale. And does this? Oh. What? Why? Why are there just a handful of things where the Leonard scale does something dramatically different?
What is this histogram of? Sorry, just at the output of the Leonard.
Sorry, this is the histogram of the scaling factor the Leonard multiplies things by. And this is telling me that there's like 20 tokens where it multiplies them by like a much bigger thing. No, I want to figure out what's up with that. Possibly this is a general lesson that models are full of weird cursed bullshit. And it is very hard to do research without getting constantly sidetracked. And possibly you should have better discipline about rabbit holes than I do, but whatever. Rabbit holes are fun. And yes. So yeah. So okay. What the hell is going on? Oh, okay, that's boring. It's the beginning of sequence token. Mystery solved. Cool. All right, I'm happy. Why does it map this to 255? What? So why do I even have a title? No one cares about titles. Oh. Oh, crap. They put this in X rather than Y. And it broke plotly. Let's just delete this graph and pretend that never happened. And hopefully Plotly will forgive me.
How are you editing those two lines simultaneously?
Oh, if you do Command D, so good IDEs give you multi-cursor support, which is fantastic. If you do Command D, it will put your cursor next to the next occurrence to the current text, which is a fantastic trick. And lets you do things like change the variable name simultaneously if you can't bother to actually use the full thing. You can also do option command down to put it at the same position on the line below.
Nice.
Keyboard shortcuts are really, really worth the effort to learn well. 10 out of 10 would recommend. Also, you get to impress people when pair programming, which is also great. Interesting. So this is the direct logic attribution, the MLP layers, and it's like, yep, that sure varies a ton. If I now restrict myself to such a useful keyboard shortcut, especially when you just have any kind of like boilerplate munging. So magical. What? Oh. What? Oh. Okay. That is not the most exciting possible outcome. Probably I have a bug. And this means I should probably actually use einsum rather than trying to do cursed tensor hacks. Are you familiar with the glorious use einsum for everything strategy?
Yep.
Good, good, good.
Callum was a big fan of that teaching arena.
He is correct to be a big fan. Great. All right, I had a bug. Okay. Yep, okay, I'm pretty happy with this. So this is the actual MLP direct logic attribution. This is the top neuron direct logic attribution. This is like much, much tighter. And I think I feel pretty satisfied to claim this is telling me something real.
Sorry, can you scroll up to the MLP one again, please? Or put them side by
Um,
side or something?
yeah, let me do that. All right.
Yeah, so it's a much bigger jump from not in brackets to in brackets, looking at the specific neurons that are the most important. Or it's a
Um,
single neuron, is it?
sorry, say that again.
So there's like a bigger jump from not in brackets to in brackets when looking at the top neuron. Is that the main takeaway you're getting from this?
Um, so the main thing I was getting is just that the band of effects on the neuron is like much, much tighter. So just like the difference between the interquartile ranges is like very short. It's like 1. And that matches the hypothesis we had. Well, the hypothesis of like, this is so flat because the model wants to control the effect on the log prop such that it does not depend on the bracket direction.
Would you not just expect them to be narrower because it's only one neuron versus
Um,
the
this
whole
is
MLP?
10 neurons. Um, sorry, so you're just saying, well, there's like many more neurons, there's like a bunch more variants, it's not super surprising.
Yeah,
Um,
exactly.
this is a reasonable enough argument. Do I agree with it? So I think that hmm. So I kind of just have a vibe of like, I don't know, man, this is so tight. This is not tight. This is surprising. Uh, okay. I guess I'm just like, this was predicted by what we saw earlier, and it's striking. Admittedly, it's kind of partially squeezed out because I decided to share the y-axes. Like, even if you zoom in, I think it is strikingly tight. But I think you make a fair point that it's not, like, overwhelmingly strong evidence on its own. Oh, yeah, sorry. This should say top neurons, not top neuron. All right. Now I want to be adventurous and try doing this for the top 5 neurons. As you said. With this glorious, glorious hack to make sure it remains a list. Because I write such beautiful and incredibly principled code. Uh, yeah, good enough for me. So, okay. So what I'm getting from this is these two are having massive effects and mostly canceling out. And if I restrict myself to a more sane range, honestly, I would say each one on its own seems less tight than the above.
Yeah, agreed. Seems like the opposite of my intuition. Single neuron has actually a lot of variance.
Which to me suggests that it's like actually doing but yeah, so well, no, okay. Wait.
Why does that look different to what it looked like before? Wasn't it tighter than that before?
I thought it was. It's possible I'm just at a very different zoom scale in a way that was pretty misleading. No, yeah, I'm on a different zoom scale in a way that is pretty misleading. If I zoom into like -5 to 5, it's like tight enough, but not incredibly so. Anyway.
And the two that are canceling out, 130 and 1338, are those the two you were looking at before originally? Those canceling
Yes.
out.
Yeah. I have updated against them being that interesting because it looks like they're mostly working together on the negative bits. Sorry. I don't know if what I just said was very coherent. It looks like they're mostly working together to make sure that when there is not a bracket, this is like much, much lower. And like yeah, like this thing. There seems to mostly matter for like this swish and not for everything else. And I'm currently trying to test the hypothesis that the neurons are working together to make this unusually flat.
But just a stupid question, like, are they not going in opposite directions even on 0 open brackets?
Yes. So it looks like what's happening is that 130 is just like hardcore down because it's got a bigger bias. This one is like slowly swishing up and like more slowly swishing upwards. Both of them have negative inputs, so they look like flat, swoosh, flat, swoosh. And they're adding together to dominate the tail of this function.
Like from that graph, it seems like sorry, the colors are very similar. Is that what 1338 at the bottom? No, other way
This
around.
is 1338. This is total. Purple is 130.
Oh, sorry, yeah.
Anyway,
But is 130 not doing kind of all of the work, really, of making it not predict
yes.
close brackets?
I think this is a fair assertion. But I think that 1338 is moderating it. So it's like, well, let's swish rather than like crashing. And it's not a priori obvious to me that the model should want to moderate it like this.
Feels reminiscent of negative name move aheads, something pulling in the opposite direction to what you'd expect.
Yeah. This doesn't seem super analogous to that to me. Mostly because, well, first off, the whole bracket to direction varying quantitatively, I don't think really has an analog in IOI. And to me, this seems like it's trying to make the model not be like too overconfident, which I think is a reasonable thing to be preventing. I don't know. Anyway.
Sorry, it's very late for me. I'm going to have to head as well.
Yes.
But
No
thanks very
worries.
much for this, Neil.
Yeah.
Pretty interesting.
Yeah. Thanks for all the engagement. This was fun. Night.
Right.